There we go.
Okay. All right. Hey, folks. Thanks for coming out. And if you didn't get a chance to sign in, just before you leave, make sure you sign in on the sign-in sheets. So I just wanted to introduce our speaker today and let you know that the reason why we're doing this week is because we're promoting open educational resources. This is International Open Education Week. And what you may know or may not know about open educational resources is that they are teaching and learning resources that are copyrighted in a way that allows instructors and students to download, retain, share, and modify those resources freely. So in effect for you, what that means is that you get your textbooks for free without having to go to the bookstore. Instructors can modify the textbooks, incorporate their own content, and can do creative things in the way they design their class. And we have Keith here who's going to present about what he does in chemistry. And the reason why I asked Keith to present today is because he's really done a lot of work to incorporate new material and do some creative things with the chemistry textbook. So hope you all enjoy. Thanks.
Okay. Oh, thank you. Thank you so much, everybody. I appreciate you coming. Sorry to keep you waiting a couple of minutes, but I do think that hopefully the lecture will be worth the wait. I, as most of you know, don't necessarily appreciate working with a PowerPoint slide. I'd rather have a vocal and interactive classroom, and so maybe we can do some of that in here too. That'd be cool. So most of y'all are familiar with me anyways, so I don't think it'll be too much of a deviation from the norm. Okay, so I wanted to thank Dr. Nathan Smith for the introduction, and he's absolutely right. This week is Open Education Week, and I do think that that is a really exciting movement that has been growing in popularity and, I don't know, acceptance, I would say, throughout the last decade, maybe even 2 or 3. But it's really taken off since the internet, and then even more user-friendly platforms that have come around, like YouTube, even Instagram, more of the newer platforms, Twitter, Facebook, all of those things have really kind of spurred this movement on. And I think that also a lot of us, Dr. Smith, myself, really embrace this movement, and I think that a lot of the other instructors that are using open educational resources are at least somewhat technologically savvy, and we can get together within these online forums and do these type of remote interactions. So the movement just keeps building, you know? And I guess like what Dr. Smith was saying, the ultimate outcome, at least from my perspective, as a proponent of the subject, is that not only do the students benefit, but the faculty benefits. The students benefit from the cost, which we'll get into the details of in a little bit, but the faculty also benefit because sometimes the curricula of chemistry or any other course, I imagine, although I only teach chemistry courses, can kind of get a little, I don't know, stale, repetitive, maybe even go in a way that you wouldn't necessarily talk about. So I oftentimes see in the textbooks problems being solved with steps missing, and that sometimes confuses students because they rely on the text as a primary resource. And the textbook, I guess, necessarily within parse some information out due to the mass of the actual textbook. You can't have your Gen Chem 1, Gen Chem 2, Organic 1, Organic 2 book all combined in one. So when you're in Organic 2 and you forget about something in Gen Chem 1 or Introductory Chemistry 1, you can't just open up that one book. And we all know if we packed all of our textbooks in our backpack, right, we probably wouldn't even be able to walk around. So I do think that, again, with the internet and with the availability of easily manipulated resources out there on the internet, some good ones are the OpenStax textbook, some self-developed labs. I think that every one of you who is a student in here, be it 1305, 1411, or 2425, has benefited in some way from those open educational resources. And in the way of not having to purchase a costly textbook, and a heavy one for that matter. So, well, gosh, I thought that I couldn't maybe fill out my hour and a half, but that was just the first slide. Now I'm introducing myself. So here I am, Professor Heath. I'm a professor of chemistry. Professor Heath Giesbrecht. I guess I should note my last name, even though most people, as you guys know, call me just Professor Heath. I think that's the moniker that's stuck mostly. That's my online avatar, I guess, as well. So not only am I a chemistry professor, but as you know, and hopefully I've introduced enough, I'm very passionate about OER, and when the chemistry division decided to create an OER development and implementation committee, I was nominated to chair that committee, and of course I was very happy to accept that nomination and be a primary developer, because as Dr. Smith noted earlier, it's been something that I've been doing for quite some time. Most of you all are familiar with the YouTube page, which I'll get into in a little bit, but it's been around since 2012. That was when Khan Academy didn't even have an organic branch. I remember when there was a competing organic channel that was absorbed by Khan Academy, and then they took over that. So it was quite, I guess what I'm really trying to say is, it was really in the nascence of at least chemistry educational videos. And the way that I actually got into it was not by choice. I was working at a different college, and it was a smaller school, and the college server wasn't equipped, although they wanted us to put our videos on the college server so they would be self-contained. It wasn't equipped to hold a massive amount of videos, and of course chemistry students, as you all know, want more and more examples, more and more videos. And back in the day, when I didn't have many videos, the students were readily volunteering themselves to be in the background, being like, okay, professor, do this problem, or do an example of this one, you know? So now that we have a pretty good library, it's rare that I'm encouraged by any of my students to do so. Although, whenever you want to, let me know, and we can close. But yeah, so I guess what I'm saying is I recorded a bunch, and it started to crash the actual college server that I was at. And of course, this didn't make the IT people very excited. So after a little give and take, I just decided to remove my videos and put them on YouTube, which to me was like the most novel idea. I don't think I'd ever even watched a YouTube video at that time. So I was pretty late to the game. I sometimes still think I am, especially walking around my classes. Y'all are like really up to date. And then you look at some of the other chemistry videos that are out there, like crash course videos and I mean, some of them are really sweet with their graphics and the things that they can do. And that's one of the really cool things I think about YouTube and OER in general, is that these materials are freely out there. And even if you're sitting in my classroom, right, and getting a lecture from me, you may think, just like I did for some of my professors back in the day, oh, he's not getting to me, or maybe he is getting to me in the wrong way, you know, or somebody else could lecture a little bit differently, and maybe, you know, I can understand them better. And I think that that's such a great thing about like YouTube and people putting even, I don't know, their simple ideas out there, you know, because that's what it started with me. It was just, like I said, my students encouraging me to do a simple problem and, you know, making a video of it, and it just kind of snowballed from there. But anyways, I'm here at the A-League campus, so if you ever want to visit with me, one day I think I'll have an office, but I'm usually walking around the halls here, or in the chemistry labs. And part of the time I'm down at Central Campus as well, and that's where I teach the official Z degree classes, the 1305 classes. So Nathan Smith is the OER coordinator. He's the, I don't know, head of all of this madness. So what is the background and purpose? Well, like we said, the background, the Z degree is a zero-cost textbook degree program that resulted from the rising costs of education impacting student attendance and course selection. So even without, I think, the burden of textbook expense, just living day to day, you know, has gotten increasingly expensive. I see some of my students not being able to attend not only extracurricular activities like this, but also class, because of family concerns, work concerns, etc., you know. And I remember back when I was in college, I wasn't a family man back then, but I certainly had a full-time job, and I could appreciate that, you know, I needed both my job to pay for my school and my school to not be doing that job forever, you know. So it was kind of a, I don't know, burning the candle at both ends situation. So whenever I could take that nap, I would, you know, and more oftentimes than not, it was when I was supposed to be walking down to class, you know, or up to class, whichever it were. But again, you know, as a concerned advisor these days, instructor, what do you say, conveyor of information, I can remember those days quite vividly, as it were, and I know that you all have even more of those types of concerns due to inflation from 20 years ago. Anyways, that being said, I find it very exciting that I can reach out to students that are having difficulties getting to class. You know, we have online classes, and that's fun for somebody who's like, okay, I'm not going to go to lecture at all. But with chemistry, right, oftentimes you might think, oh, I can get A's in everything, but chemistry problems, there's sometimes you just need to have somebody solve a problem before you can sit down and actually solve it yourself. And that's what I was really finding was when I was teaching back in that college that I had mentioned, was I was teaching online classes, and the students really had a bunch of problems keeping up with the material. I think that even in a 2-lecture-a-week class, sometimes if you're not putting all of the effort into it, it is still challenging to keep up. And if you're taking an advanced class, my goodness, you know, sometimes it's challenging to keep up if you're working at it every day. So, again, I can appreciate that and the background of the Z degree program. So you probably can read the second line. It's more of what I was saying. So the purpose of what we're doing is development and implementation of the Z-degree chemistry courses for the division to benefit the greatest number of students and faculty. So, and like I said, in all of my classes, I offer at least some sort of component that's OER. If I could, I would offer it all. But, you know, there's rules and regulations, as it were. So we do as much as we can, I guess. What do I say? I'm encouraged to see such a big crowd here, you know, and hopefully you're encouraged by the way this is going, and maybe you'll spread the word to your fellow classmates or, you know, others that are taking chemistry or other types of classes, that there are these classes out there. So with that being said, what is a Z-degree? It's a pilot program where HCC invites registration for an associate degree in either business administration or an undeclared major, where the student can earn this associate degree with zero cost for textbooks. So all courses require only open access and open educational resources. So as I was saying, a lot of you are in other courses of mine, maybe my 1411, my Organic 2 course. Those are not officially Z-degree classes, so it's not everything is free, you know. But the 1305 course, if you were able to come up here from Central or from the online course, I'm sure you know that there's no course materials that you had to pay for. You just download an online book and that's that. But a lot of y'all have a similar instance, at least with part of your educational resources in the class. Let me see, where are we? So, yeah, what are open educational resources? I think Dr. Smith covered this earlier, but they're high quality teaching, learning, and resources that reside in the public domain. You can read most of this, but if, in fact, you know, if there's a Creative Commons license on there, we can take it and we can use it in our courses. Okay, so I'll get into the copyright in a second, but I personally, and anyone who's in the chemistry OER D&I committee, can and does develop course material, and we put it into a communal shell, if you will. I'll have to admit that since I had such a long or extensive background in this, I have developed quite a bit of them and just given a lot of them out to other instructors. But that being said, they have developed their own pieces. They've encouraged me to put this and that in there, and we do it as a group, as a committee, you know. So the courses that you're getting are kind of vetted courses, okay? So it's not just Professor who thinks this is the greatest way to do it. It's a whole committee saying this is the way these are done, okay? That being said, it's a developmental process, okay? And that's being, what do you say, implied by the name or directly said. So we've got to keep that in mind as we go along. In fact, I think that's sometimes a point of discouragement for instructors wanting to adopt this type of material, is that they say, well, it might be so overwhelming, you know, how can I develop a whole course, or how can I write a whole textbook, you know? What if I make a mistake? My goodness, when I look at the published textbooks, there's mistakes in those. What if I leave something out? Something like that. I would feel responsible. Well, that's the case with anything, right? I'm sure we've all misgraded a test before, right? We've all, I don't know, misspoke in lecture, right? We said upfield when we meant downfield. We said negative 256 kilojoules when we meant positive 256 kilojoules. Okay, and then a student corrects us. I remember earlier in my career when I would always be all nervous nervous when a student would correct me. These days, right, I take it graciously, right, because they're right, you're wrong, right? Just take it and move on. And that's what we want to have, that same kind of identity with our courses, right? Yeah, we're not going to be able to build a whole textbook by tomorrow, but in incremental steps, right? We do a little bit of, it's just like what I tell my students. Do a little bit of chemistry every day. You'll get a little bit further, right? As long as you're doing some chemistry, that's better than nothing, okay? In fact, sometimes it's not good to do hours and hours and hours of chemistry. So, anyways, let's move on. But I am committed to continuing developing course material, video resources, ancillary resources, and even full courses in OER. So what is this OER impact that we've been talking about? So this is coming from Tidewater Community College. This is in Virginia. You can see here these numbers that they have, right? $2,400 for their traditional degree is being shaved off when they go to the Z degree modality. So you can still see that tuition, right? The college still wants their cut. But you may think, and this was something that was surprising to me when I learned it, is that the college has no, what do you say, control over the bookstore. In fact, the bookstore is a Barnes & Noble bookstore. I didn't know that until just recently. And so oftentimes, you know, I tell my students, you know, I didn't make up that copper's molecular or atomic weight is 63.55 AMU, right? That's the answer, and if you didn't put that on the test, right, then it's going to be wrong, okay? No matter if you're upset about it or not, okay? I didn't make a nucleophile be a nucleophile or be called a nucleophile, okay? But I'm going to teach it as such, okay? It's the same thing. Well, it's the same thing with everything. So, let me see. We've talked about some of these other ancillary benefits to going OER, right? Besides the student saving, faculty engagement. Like I was saying, sometimes if we're looking at it as our own project, it might be a little overwhelming. But when we take it as a committee or as a part, we can bite off little bits of it at a time, and over time we can build an entire lecture, okay? Or an entire course, or an entire quiz, an entire subset of quiz questions, right? Sometimes, you know, we build quiz questions and we find they're too easy. Sometimes we find they're too hard, right? We can always put more detail into that. Maybe we can start ranking the quiz by some sort of taxonomy, right? Quiz questions. Maybe we do 5 level 1 questions, 5 level 2 questions, or something like that. So there's always more and more, I guess, detail that you can go into with this. So even if, like, for example, my 1305 course, I would say that course is done, as it were. If I go back to it today, I guarantee you, I start looking at it, I guarantee you I'll start messing with things. And it'll be better by tomorrow, okay? So, is it really ever done? That's the one thing I really think is encouraging about OER. And the other cool thing is that it's not just our committee as in HCC, right? The committee is the Facebook group that we're in, right? Is the conference that we're going to, the OER conference that we're going to. In fact, I think that the OER community is getting so large, and so apt to donate freely and actually accept freely without, what do you say, having their ego hurt. Oftentimes, you know, in the past when somebody might say, you know, if your course will be improved by doing this, I might have taken it as a slight, you know. But I certainly will tell my student, you know, if you would change your study habits to doing this way, right, you would probably get a better grade. And they may take that personally, but I don't mean it personally. I mean it improve their study habits, you know. So I think that when we kind of remember that we only learn when we kind of do it wrong and then have to do it right, then we recall what it's like to be a student, and we're continually being a student, and we're continually, instead of just managing a course, right, we're continually building that course. And I think it really, I mean, we all know Gen Chem like the back of our hand. We all know organic like the back of our hand. But, thank you so much. This makes it a little bit more interesting and a little bit more your own when you do it this way. You can incorporate things that maybe were from your own research, from your own interests. Okay, so we talked about the copyright. So if it's CC BY, right? All OER materials first developed shall bear the copyright insignia, followed by the year created, and then bear the CC BY symbol. Material for lab fees or lab classes, if they're actually material fees or items, can they be an OER? Well, one of the sticking points for chemistry faculty is that they love these two programs, Mastering Chemistry and OWL. And the students all don't like them anyways, you know. None of us that are faculty now learned using OWL or Mastering Chemistry, not a single one of us. Maybe in 10 years, chemistry faculty will have learned that way. But right now, I know for a fact that each and every one of us can remember a time when we were sitting there with a pencil or a pen and a piece of paper and writing down our problems. And that still is the best way to solve chemistry problems. If I'm solving chemistry problems on a computer, say a mechanism of a reaction, and I'm drawing an arrow on a computer, I don't get that same muscle memory that I do when I'm drawing it on a piece of paper with my hand. And that's just borne out by, what do you say, grades. Whenever you look at grades from students that have written out a bunch of problems as opposed to ones that haven't. So it always goes back to, again, I don't like to say memorize because chemistry really isn't a memorization type subject, but it is a process. So it's like, you know, many of you have heard me say, you don't learn how to dunk by sitting there watching a basketball game where LeBron James dunks the ball all over the place, right? You can't expect to go outside and dunk the ball. It's just not going to happen. You can't expect to drive a car by watching a NASCAR race. It just doesn't happen. Or even reading the owner's manual. How many of us can drive, right? Raise your hands if you can drive. Everybody almost in here, right? Some people probably are just not raising their hands. How many of y'all have read the owner's manual to your car? Exactly, right? So it's very similar to that. I just want us all to keep in mind what we're doing. Okay, so let's look at textbook costs now. So chemistry is a subject that has a lot of information, right? So I guess our books need to be very dense and thought about a lot, so that means that we're one of the top of the list, okay? So this is the University of Virginia. You might think, my goodness, you know, that doesn't apply to us. That's such a top-tier school. They probably have the best of the best. That's not even in Texas, right? But what you'll find is, if not, so this is the cost of textbooks per class is $262, okay? Ours is very similar to that, okay? Look at the textbook cost. Two of the 10 most expensive textbooks in the same study are chemistry textbooks. So think about that. At UVA, those are those classes that if you're a U of H student, you may have been in, you know, maybe 150, 200 people in a lecture, right? Imagine how much the textbook companies are getting off of this, how much Barnes and Noble, right? That is not going back to the core education at UVA, at HCC. It's not coming back to your instructors, right? It is making you more frustrated with your class. You think, my goodness, I have to work this many more hours, so I don't get to be with my kids this many more hours, so I don't get to spend this many more hours studying for my chemistry that I'm doing it to begin with, right? Why should we have to force our students to do that when we all have that material in our heads? We're all a textbook, my goodness. We could all do this standing up here talking like I was telling you all, right? I could probably stand up here and talk for an hour and a half about that first slide. Okay? So, how do I say it? It is something that we at least want to think about, especially as chemistry instructors, for our students. Okay, so I'd like to play a video, I'll play an audio recording. And just because I had mentioned UVA relative to HCC, and hopefully we can hear this. We just set this up before.
Okay, and that price isn't up there? No. Okay. What about the 1411 textbook?
1411 textbook is $130.
Okay.
$135.
And
1412 is $115.05.
And the lab book?
The lab book is like $45.
It's not there anymore, or?
I have 1412.
Okay, yeah. How much is that one?
I can check up on it.
Okay. How much is the organic one book?
$178.95.
Okay, and the organic two book?
I have to check on that one too.
Okay.
The lab manual is $45 for 1411 is 40.
Okay, and it looks like, is that a 1411 tag right there?
No.
It says Chem 1411. Oh, no, CHN. And 1305?
1305. That was in 167.85.
And is there 1105? I'm so sorry.
1105, that's the access code.
Oh, okay, yeah.
Yeah, that access code is 3750.
Okay, cool. Thank you so much.
Okay.
Right here is 158.55.
And that's the organic sheet. Okay, cool.
Okay, and there was one they didn't have at the Barnes & Noble textbook store over there, next door to where we are right now, which was the organic lab book, right, which costs $136.45. So that gives us a total cost of our chemistry books at $1,008.60. So that may not be very much for you, right? Maybe you can write a check for $1,000, right, and it's no big deal. But many of our students find that cost to be a high burden to bear. So I encourage you to, if for nothing else, think about your students while you're doing this. Yes, they may give you a hard time about turning in homework because it's harder to do than mastering chemistry. You're going to have to work with them, okay? You're always going to have an issue. A student's always going to come to you and complain. When was the last semester that you had a student, or a complaint-free semester? I can't remember one. I've been teaching for over a decade. Okay? I love the student complaints. because they give me a chance to improve my teaching, okay? Not only my, teaching as in chemistry teaching, but teaching as in personal interaction teaching. I think that many of us in here have been in a stressful situation in chemistry, myself included, right? And, you know, we may have misinterpreted something or other. It's up to the professor to be there for the student. And what better way to be there for them than to show them this type of data and show them that, yes, it might be a little bit more strange to upload your pictures in Canvas for homework or do whatever. But at least you're not having to buy these textbooks for $1,000. So the other thing that's not included in here is, remember what we were saying, the AL costs and the Master in Chemistry costs. Those are two other costs that we have gotten rid of if we go to OER, okay? And again, recall, not a single one of us in here used AL for Master in Chemistry, okay? Are we not good chemists because of it? Or does it just make our lives easier because the AL or Master in Chemistry gives us a grade back and we just have to transfer that into the grade book? Or if you're tech savvy enough, you can just set it up to be a one-button push and it pushes on it. Okay? So you think about $200 more added to this. Maybe $300. Okay, so some faculty responses, right? When we surveyed the students about the free materials, most said they were just as good, if not better than the paid one. I didn't go into teaching to work for the bookstore or the publisher. I went into teaching to help students. Okay? If you have the power to make an economic issue go away for someone, then you should. I could not, in good conscience, ask students to spend $400 for a book when there was an equal quality free alternative. So the book that we use in our Z degree class is the OpenStax textbook. It's published by Rice University, okay? Very well-known university, very top tier. Okay? They're not going to publish something that is subpar. Funded by the Bill and Melinda Gates Foundation. So again, I think those two facts speak for themselves. You could talk to your students that may have used the OpenStax textbook or an OER resource for their first semester or their second semester if they come back in class. See what they think. You don't have to take my word for it. Okay, so right now on a sheet of paper, finish this sentence. If I could fix one thing in my class, it would be. Okay, I'll give you a second. We just took a test, so I'm in the mode of being like, okay, one more minute, no more writing. Okay. So 4 common findings that this often uncovers are support for new instructional approaches. I think we've covered that previously in the lecture that we were talking about. Unique instructional capabilities, increased teacher engagement, and student motivation. Okay, so let's continue to think about these while we're talking about our project objectives here. So the project objectives for this OER D&I committee, or the Z degree in general, were to identify faculty visionaries and form an OER D&I committee, development and implementation committee. Use a multi-member team approach, including faculty, administrators, or other content-focused staff in an OER D&I committee. Testing and assessment materials posted to Canvas. integrity checks by anyone in the OER D&I committee, access for maintenance and accuracy, ensure OER D&I faculty have flexibility to update and customize degree content, course content, consult with OER coordinator on course goals and plans. So it's not just a self-promoting thing, right? You can go outside and get ideas. And identifying areas for procurement of funds to provide professional development and technical assistance for OER D&I committee course development. Now, this may or may not happen, but it's always nice to have money as an ultimate goal. So some more faculty responses in regards to these particulars. OER invite faculty play a direct role in making higher education more accessible. You're the ones who are out there on the front lines, knowing what your students are dealing with, knowing what their knowledge of the subject matter is. Do you need to put more information in there? Are the mechanisms complete? Do they have every step? Does the student remember SN2 from Organic 1? Do they remember how to calculate moles? Should we give them that step? There's a lot of questions there. How do you approach it? You're the one that's the subject matter expert in the classroom. The textbook company is not the subject matter expert in the classroom. You are. You have the ability to change that material. You have now the ability to change that material. Do you understand? It's very, very empowering. You are the coordinator. You are the boss. It's not the textbook company telling you what to do. You aren't committed to using a new textbook. You're committed to being open to being open. I think that says it all. What are we really trying to do here? Do we all have the same goals in mind? I think that if we surveyed every one of us, it would be to do what's best for our students, okay? And maybe that's not what they want. Maybe that's not sometimes what you want. Yes, if you do OER, right, you convert to OER, you're not going to have that resource, the Mastering Chemistry resource. You're going to have to do a little bit more grading of your homeworks. You're going to have to find some class time to do review sessions, to engage those students. And I know it's tough sometimes to pull those students out of their shells, especially when it's in chemistry, in terms of chemistry. It's very difficult. They don't want to talk about chemistry, just like you don't want to talk about, I don't know, the Icelandic language, okay? Probably because you'd be nervous if you just jumped into a course of Icelandic, or I don't even know what it's called. Is that the name of it? I don't know. Just like chemistry is a foreign language to a lot of these students. And to really engage is we have to break down those walls, those barriers. They have to realize that we care about them. We care about them enough that if they get it wrong, right, we still want them to keep going and keep trying. I know their peers are there, and that is a very high burden as well for them. That's why office hours are there. And that's why the student sometimes will say, I want to come to you in private. And then they say, oh, can we convert moles? You know, and you say, well, we could have done this in class. Oh, I wanted to do it here. It's good to encourage your students to come out, to get that interaction going, because those are the types of real-world problems that they're going to have to face within the context of whatever their career is. I mean, even us as a professor Even us as a research scientist, we had to go to a conference, we had to present our results, we had to present them in a manner that was convincing. Okay? Convincing to difficult questions. And that's what your students face. You might think those questions are very easy, but those students are feeling that they're on a, I don't know, a PhD panel, you know? They're getting ready to, I don't know, do the hardest thing that they've ever done in their life. So we're here to, you know, encourage them in any way that we can. And I think showing them initially that we have their best interest in mind personally is the best way to start off that process. Start off that, I don't know, mentorship process, I guess is the best way to say it. Okay, so if you're looking for some chemistry OER resources, I have some here, the ones that I use, of course. You'll see in when we get into the course that these are all integrated within the course shell itself. So feel free to look at these. You can take pictures or whatever. Okay, so this is our students. They have lives of online engagement. All right, 8 to 18-year-olds. I didn't put the citation, but I think this study was a couple years ago, so we'll say these are our students, right? 6.5 hours of media per day, 4 hours of video, TV, an hour and 45 minutes of music, an hour using the computer other than schoolwork, 45 minutes video games, 43 minutes recreational reading. I do my recreational reading on the computer. I listen to it. That's how bad I am, right? It happens when I'm driving back and forth, but never a minute wasted in my book. So 26% of the time, students are using more than 2 of these media types simultaneously. Are you getting to your students? Student engagement needs to happen where the students are. Where are your students? Do they have their nose in a textbook? Probably not. I'll bet you, every day I survey my students and I say, how many of y'all read the textbook prior to coming to class, okay? And it's always a chore for them to raise their hand, even though they know I won't get upset or anything, right? Because, why? Because it is a chore to get out that textbook and read it, okay? It's a chore to carry it around. It's a chore to take out your notebook. My goodness. We need to engage them where they are. If they're on YouTube, put your stuff on YouTube if you want to teach them chemistry. Right? If your students are on Instagram, right? Put your stuff on Instagram. Do it where they are. What are you here for? Are you here for the students? Rhetorical question. I know we all are. Okay, so like I was saying, we're going to go through a little bit about course setup, course design now. Okay, so all the learning happens in one place. So I showed you all of those diverse resources that I use within the context of my chemistry shell, my chemistry courses. Okay, but there's a central location, a central hub that the students go to, and they link out from there. Okay, so the least keystrokes possible. Sometimes we can get inundated with subfolders and subfolders, and students can't find things. Sometimes we think those files are there because we copied them over, but some folder didn't come up. That happens regularly. So it's best for both student and professor if you keep these kind of best practices in mind. So, like I said, all outside sources are directly linked from the course. So, therefore, like I said, a hub site is dedicated to the course. So my students all go to one place, which is the Canvas shell, and link out from there. So we'll click on that. we'll just pretend it opened up in Chrome. Okay, so you can see here, here's the 1305 course shell, the Z degree course shell. Oh, you can't see it. How do I switch back and forth?
And escape out of the presentation mode.
No matter. We'll just do this for right now. It's all right. We'll keep going. Yeah. Cool. Okay, perfect. Sorry about that. So here's the 1305 course shell. And you can see it looks like any normal course shell with the Z degree insignia. But what I really pride myself in is when you go to, of course, the modules is, the modules tab is the table of contents of all these shells. And we can just scroll down to some shell, we'll say module 6, 1305, right? So we're learning about molecular and ionic compounds and chemical nomenclature. So if we click on one of these, so 6.1 we'll call it. So what you can see is what I've done, and I do this for all of my classes. I take the textbook and I whittle it down to the essentials, at least what I think are the essentials, and I post them within the course shell. The Lumen platform has an easy way of doing this. So you just manipulate the Candela or Waymaker course, and then it will be imported into your Canvas course shell. But what I choose to do is kind of do it a little differently. I make my own course shell kind of based off of my materials, their materials, all of them. But this one is, in particular, is based off of the OpenStax Adams First textbook, which, if you recall, the Corwin text is our 1305, Chemistry 1305 text. And even though the topics don't come in the same order as the Corwin text, we can rearrange it within the Canvas shell to, instead of the chapters, we do it as modules, okay? And those modules will directly correlate. So if maybe your student is going to go for the 1105 afterwards, or is taking 1105 concurrently, they won't be at a different place than a student who is using the Corwin text. They'll be at the exact same place. Okay, so that's the way I built it, to where they're coordinated. It doesn't matter which text you're using. Okay, but anyways, you can see here, we have learning objectives, figures, I think very nice figures, but periodic tables. But what happens is when we scroll down, for me personally, like I have been mentioning over and over, I really appreciate recording myself because my students appreciate it. I personally never liked to be recorded before this happened, right? But I did it and it wasn't so bad. Okay, yes, you'll get maybe a silly comment on YouTube here and there, you know, but other than that, right, it's not that big of a deal. But even if you're a little shy, you can just have your voice on the video, right, and write with your hand, and I'm sure the students would appreciate that. Oftentimes, the students really do appreciate your teaching style, but they have to reach out to a different instructor because you are not there when they're doing their homework, right? They're doing their homework at night, They say, well, I guess I'm going to Khan Academy now, you know, because Professor X or Y doesn't have a secondary or ancillary resource for me to go to. And that has nothing to do with you, except for the fact that it is possible to start producing them. And again, I don't want to make it sound like it's such a daunting task. I have thousands of videos now, but how come I was able to do it? Is because every time somebody wanted a recording, I just said, okay, 3 minutes here, 3 minutes there. After 3 years, right, if you do one every day, that's 1,000 videos, okay? If you do a review session, how many problems do you do in that review session? 10, 12, right? You do 12 review session problems, you just record them all, put them all up there, you got 12 for that. So I found it to be daunting when I looked at it from an outside perspective. But I found it to be very natural and very easy, I guess, for lack of a better word, to just push record when I was just going to stand up there at the board and do a problem. So I just encourage you all to do something like that and try it out. If it doesn't work for you, then fine. You work on ancillary resources, work on worksheets, work on this or that. You don't have to do what I do. In fact, it would be a very boring world if we all did the same thing. Not only that, we don't need 15 committee members making videos. We need us to do what we are best at and what we feel most comfortable in. That's what we want to contribute. Okay? If you feel comfortable doing this, if you feel comfortable just using these resources, I want you to be on the committee to use the resources, because I know they are beneficial to the students. Okay, so imagine this to be a neutral atom. What would be the atomic mass of this atom? Helium-4 is going to have an atomic mass of 4. I didn't want to name it because I would have given it away, but as you can see, if you can't see it from this angle, you can see it in the back there on the video screen. But this problem that we're listening to here, and if you're listening to this on the audio recording, there isn't two of them, right? There's a virtual video that's playing right now, and I'm solving the example problem that I presented before. So you might say, well, I can write an example problem. Great. You write an example problem, I'll record a video, and then the thing's done. Okay? Then we never have to do that problem again. And we're both vetting that problem. Okay? We're both sitting there vetting it. So, if 2 professional chemistry instructors cannot appropriately vet a problem, then that problem is too difficult for your students to be doing. So just keep that all in mind. It doesn't take very long to do. Okay? The cool thing is, like we were saying at the beginning of this lecture, this community is worldwide, and it's so localized, it's right there in your pocket in your phone, right there in your office on your computer. You can just reach out to your Facebook friends, your OER Facebook group, your YouTube lectures, right? ACS has a lecture series on YouTube. Anybody can go watch it. Okay? So I oftentimes hear that one of the barriers for instructors to start this is the magnitude of the project. But it's because we're just at the beginning. But just like if somebody were to look at the pyramid as a whole, we'll say, or a building as a whole, right? They would say, not one person can do that. But that's probably true. Whenever we see a building being built, there's dozens of workmen, dozens of work people out there, okay? Foremen, concrete people, tractor people, bricklaying people, electricians, they all have their own specialty. You don't want your electrician to be pouring your concrete. Okay, so that's what we want to think about. What is our own specialty? What have we been designed to do? What do we think we can contribute? Okay, let's see if we can get this thing back. Okay, so the links to the highlighted external site, right? So the Canvas page, the course announcements, the internal messaging usage. You probably know where that is, so I probably don't have to tell you, but I use these two tabs quite frequently. Especially because students really like the interaction. In fact, if you don't respond to a student, they'll respond several times. Maybe even go up the chain of command to respond. So I think a really good response rate is 48 hours per internal message. I encourage you also to encourage your students to use the internal messaging system on the Canvas page. Again, so they don't have to, and you don't have to monitor your work email at the same time as your Canvas email. So you know all those emails coming from the Canvas page are pertinent student questions, so you won't overlook those. Because they are oftentimes, you know, needing to be solved in a timely manner. The integration of the OpenStax text, like I commented before, it's imperative to order the topics in the same sequence as the adopted text. If not, get ready for division blowback, okay? They have the right to expect that you will be teaching in the same order as the textbook that has been adopted. So if there's a concurrent course, or if there's a subsequent course, those students need to know that information in that order. So make sure you're using the recommended topic order. And then the YouTube page for targeted lecture and problem solving we talked about. I have a complete video library. It's simple video production, concisely targeted 5 to 15 minute videos published to web. I only need my iPhone these days that has a good enough camera. Dynamic medium for delivery of reinforced content. Content easily uploaded, organized, and universally accessible. Statistics of the usage are logged. HCC students praise the convenience and reliability. Some students don't like it too. You'll hear from every once in a while, but most of the time, the more positive students aren't as vocal as the more negative students, but I think we all know that. Even in our own instance, right? You don't go to the chef at the waiter and say, this was a great meal every time you have a great meal, but certainly if there's a fly in the soup or a hair, you're going to tell somebody, okay? So just got to keep that in mind. It's human nature, right? HCC students are highly engaged in the medium. Everybody uses YouTube. In fact, for the students here, raise your hand if you use YouTube. Yeah. How many people have watched a YouTube video in the last 48 hours? Raise your hand. Everyone. Okay, every single person in here raise their hand, okay? Why not engage them there? You know, if they are taking your class, you know the Professor Heath video is going to come up in their feed, and they're going to either have to ignore it and be like, oh, I'm ignoring that, or watch it. Either way is good, okay? Or whichever professor you are. So I just want to compare my YouTube page, and sorry for the green-red if you're colorblind, I didn't even think about that. But the University of Georgia, this is this ACS publication that I've linked, or I've tagged down here. But you can see the University of Georgia has sponsored an in-house YouTube page with a complete video library, targeted 5 to 15-minute video production, using a tablet, and their freely available editing software, and they recommend you use a 30-minute block of time per video, okay? That's a little bit more cumbersome than my system, which is just a click and go and move on with your life. But I can imagine that if you're new at it and you want to take the time to produce a very well-organized video, that you can do these types of things. Get different camera angles, maybe if you want to do a video production of an experiment, right? It might take several video takes. What do you say? Statistics of the usage are logged. The UGA students praise the convenience and reliability, and they're highly engaged in the medium, tallying over 100,000 views per year. So if you compare that to my YouTube page, it's unsponsored by the college, self-funded. Okay, all the rest are the same, just the red things are different. And HCC students are highly engaged in the medium, tallying over 480,800. Okay, so imagine what we could do if HCC was fully engaged like UGA was. Imagine not only if it was just one person producing videos, but the entire chemistry contingent. I don't know the exact numbers, but I can guarantee you we have double, at least, the faculty members, chemistry-wise, at HCC that UGA is. We're all professionals just like them. They have PhDs, master's degrees. We have PhDs, master's degrees. Why aren't we doing this? Why aren't we? This is for our students, right? 400, almost 500,000 views per year. This is an unfunded YouTube page. So, why is a YouTube page so important? Well, we were talking about statistics, right? You can learn a lot from some statistics. Here are some, if you have a YouTube page, you're probably familiar with some of these analytics that you can get from it. Right here is the number of views from the beginning, right? And you can see at the beginning, when I started, just like what I said, I just threw them on there and people eventually just started watching them. I was not my intention, but to have my students watch them. And now they've ballooned to, what is it, about 3 million views. So that's just since March 3rd, 2012. So keep that in mind too. I mean, what kind of reach does a normal ACS publication have? Journal of Chem Ed, right? What kind of reach do you have as an educator? Do you have 500,000 view reach, right? Can you influence people on the other side of the country, on the other side of the globe, that might be interested in taking an HCC course, right? Might be interested in taking an HCC course from you? You can look at things like the average duration of view. Okay? Am I making my videos too long, too short? Right? 2 minutes per view. That kind of gives you an idea about the attention span your students might have when you're talking in a lecture like this. Or, gas in your lectures. Right? Half of the students, if I'm not going over there saying, hey, write it down, whatever, right? They're not engaged. I think I got more compliments from my students. I get compliments from my students quite often on my lectures, right? But I got more compliments after the review sessions than the lectures. Why? Because the students felt confident and they were engaged, okay? They had that backstory of being studied for getting prepared for that exam, right? So we could actually have a meaningful conversation about chemistry. Those are the types of conversations we want to have every day. Why don't we start it out first day, right? But we can't change the system one instructor at a time. We have to encourage the students to understand that the old system of learning just doesn't apply to our new and integrated world. The students of today are asked to be so multitasked, right? So integrated into society that is so kind of foreign from what we were growing up with. Okay? I think it always comes back to the engagement thing. Where do we engage our students? Some other things that we can get from this are, which videos are the students engaging in the most? Okay? And what are they doing with them? We can get real-time views. What's happened in the last 48 hours? 5,300 views. Okay? If I scrolled down on this page, I could see which videos were being viewed. I could see which videos were viewed in the last 60 minutes, these 93 videos. I could click on them, okay, see which ones were viewed how many times. Anyways, if you want some more resources, ACS resources, here you go. There's the Georgia Tech, or the UGA study at the top there. Okay, this is just going back to the Canvas shell, and I was, didn't know if we would be able to actually link back to the internet and see the Canvas page, but since we've done it, we can like kind of skip through this. But this is just going through problems, and if we wanted to link back to the YouTube page.
Let's suppose that you're writing a really important email to a colleague.
So the time of it is really
Sure. I think that, you know, these days people need it like so small to be digestible, or, you know, they'll lose their interest or something really quick.
Yeah.
You know? So that's why I'm doing one problem. Yeah. It's ironic that even on the video that I just randomly chose to play, I said the exact same thing that I'm saying in this lecture. Why is that? I didn't choose to play that. It's because it's so pervasive in today's learning environment that we have to have these bite-sized digestible pieces, or the students are not going to be able to learn appropriately. Anyways, like I said, I'm not going to bore you through going through this portion of the lecture since we already did. Although I do think some of this is cool, like if we look at a mole, this is a mole of copper, a mole of aluminum, mole of iron, mole of sulfur, right? They all have how many atoms in them? 6.022 times 10 to the 23rd. Yeah, very good. But look, they're different sizes, right? Different masses too. Pretty interesting stuff. And that all their masses, right, they equal the number on the periodic table. Pretty amazing. Okay, so what do we think? Right? Instructor expectations, we've talked about this. You have a good idea, incorporate it into your course. Because you are the subject matter expert, it is a good idea. For course development, it's an ongoing process. My basketball coach in high school used to always tell us, Rome wasn't built in a day, you know, so keep working, keep working. You keep working at it, your class will not be built in a day, but eventually it will be built. For the first iteration, and it's a point value assignment, make it worth minimal points until the kinks are worked out. Or if you don't, give the students plenty of leeway to return it in, because it's a technical glitch. It has nothing to do with chemistry, right? You don't want to punish them for something like that, okay? So just keep that in mind. You're going to have to work a little bit harder until you work all the kinks out. Once the kinks are worked out, it's just like anything else. You don't have to worry about it anymore, okay? Course change ideas sometimes do not go as planned. Do not let this deter you from making future adjustments. Okay? If we stopped doing everything the moment we made a mistake, we wouldn't do anything. Okay? So an idea never works exactly as planned. the first course iteration. Just like an idea that you have never works out. Like you imagine a conversation right now, for maybe your significant other, about what you want to eat for lunch or dinner. Okay? Imagine that conversation. Go home and talk to them about it. I guarantee you, even that simple conversation will not go as planned. Okay? So it's not a failure if it doesn't go as planned. Okay? But it will seem something like this dartboard that we see here. Adjustment after failure is just a good idea working itself out. So it's just like you tell your students. You tell your students, it's okay to make a mistake in front of everybody. Don't be embarrassed. Keep making that mistake. They get embarrassed, you say, no, make that mistake again. But then you're not willing to make a mistake in front of everybody? What's the best way to lead? Is by example, right? The best way to lead by example. It's encouraging to your students to understand that even you are fallible. Okay? It's encouraging to your students to understand that it's okay to make mistakes. It's okay to be wrong as long as we correct them and correct them graciously. I think that's the key. Yeah. So I could go on. No, I could go on. I could go on. The next part would be about how I personally teach, but you all know all about that since I think everyone who's left knows me personally. So I think this is a great stopping point, and I really do appreciate all of your time. If there, Nathan.
No, that's great.
Yeah. So if there are any questions or anything like that, feel free. Yes.
When I started high school, here in ACC, I heard about the C degree, but they told me it was just about business and not careers. I didn't know it was for chemistry too.
Sure.
So
Yeah. So
where do we find more information about that? Because I want to get classes like the chemistry one. We should have information online. And
yeah, it's actually unfortunate that there isn't more marketing for this particular program. Oftentimes, I think both semesters that I've had Z-degree classes, 90% of the students didn't realize they were in a Z-degree class even. Yeah, just like you were saying right now. There is a gentleman here, the gentleman who introduced me today, Dr. Smith. He's the OER coordinator, and he's in charge of the Z degree, him and his immediate supervisor, Dr. Levy. And I think if you just talk to him, he can give you more of an overview of the additional classes. Although, from my perspective, I am always putting the word out to the division, the chemistry division, to increase the number of OER classes that we are offering. But, you know, how do I say? Change takes time, I guess is the best way to say it. But certainly these other classes, maybe not chemistry, but other classes, you should check with the appropriate individuals and they can help you. Any other questions?
I'll just try to add on to that.
Sure.
If anybody's interested in learning more about the Z degree, you can go to hccs.edu /Z degree, just the Z degree. That'll take you to a web page that has some information. There's a form on there that you can fill out and put your information there, and then we'll be in touch with you about it. So next, look for the fall semester. We should be at Spring Branch and Stafford, as well as Central and North Line. And we're offering classes in the general education sort of core curriculum area. So if you're interested in taking those classes, or you need to fill your core, or if you have classes to take, then they would be available at those campuses as well as online.
Any other questions? Yes.
Is this just for online class or face-to-face class too?
No, it's for both classes. In fact, I have 2 official Z degree classes this semester, so those are the ones with totally OER, right? I believe the 1305 online and the 1305 face-to-face. Are you in one of those classes?
1305 online.
Online class, yeah. So I believe that you were on one of those classes. Yeah, so those classes, one is online and one is face-to-face. And me personally, if I have an online class, I always am encouraging my students that are online, if they would like to come in and audit the face-to-face class, or just as a topic, to come in and sit in on it, I would love to have them, you know. Or if they would, you know, want to come to office hours and, you know, kind of get more information about how to manipulate or work through the class, I'm all for that too. But yeah, certainly they're both online and face-to-face. And maybe, do you have any hybrids or?
Some people teach hybrid, so yeah.
Okay, sure.
Yeah.
So,
We count those as face-to-face essentially.
yes, sir.
Yeah. Yep.
Any other questions? Okay, well, you've been a great audience. Like everyone knows here, I could talk all night, you know, so I'll try to cut it off now. I appreciate you all coming, and have a good night. If you have any questions that you wanted to just address personally, feel free to come on down here and we can do this.